what are their characteristics, how we can do that. Okay. So we already know that India is generating a lot of solid waste, approximately around 1.85 lakh tons of municipal solid waste daily, and which amounts to over 62 million tons annually. Okay, so there are a lot of solid municipal solid waste that is being generated in India, and the government also give things mandatory, like under solid waste management rules this year. So government has advised to keep wet waste, dry waste separated. Like if you are generating kitchen waste, vegetables, fruits, peels, meats, and flour kind of a kitchen waste, then you can keep it separated, and that can be composted or processed through biomethanation in nearest facility. Okay, so this can be either composted, or it can be either anaerobically digested for energy production or fertilizer production. So wet waste could be separated or segregated in a separated manner. Dry waste is another thing that is kind of like a plastic waste, paper waste, metal, glass, wood, and rubber kind of a waste that can be transported to metal recovery or material recovery facility. Okay, so what they do, they will recover the materials if there is some valuable material in the waste, or valuable rare earth metals in the waste, so they can be recovered and stored for the recycling purposes. Some sanitary waste is also being generated, and which can be used in a child's, used as a diaper, sanitary towels, and tampons, this kind of a sanitary waste in a household or in a hospital. These are generated, and this can be securely wrapped and stored separately. And special care of waste, paint cans, bulbs, mercury thermometers, medicines, so these can be collected by authorized agents or deposited at a designated collection center. So government has, under solid waste management rules, advised to keep these four things separated, segregated manner, so that upper channel can be collected. Municipal solid waste characterization is one of the important thing in a municipal solid waste management. So it has several characteristics, parameters, such as physical characteristics, chemical characteristics, and biological characteristics. So what comes under physical? So these are composition, moisture content, and density, and some size and color also. So physical characterization mostly focuses on the components, size, density of the waste streams that is generated, and it will determine the handling and sorting needs that as per the needs. The composition, that could be the type of a material present. So some of the materials are organic materials, some of the materials are inorganic materials. So organics could be like a food and garden waste or kitchen waste, and it also contains a large fraction of a solid waste that is generated in a household, urban or rural household. And inorganic portion, glass and some kind of metallic components also. The moisture content is also like a 20 to 40% moisture is in solid waste. If it is a kitchen or wet waste, then it has a larger fraction of moisture in that, more than 20%. And if it is other kind of a waste, then it could be less. So moisture is directly affects the waste density, biological decomposition rate, and also affects the whether the waste is suitable for incineration and incineration. So it can be if it is a wet waste, then it can directly transport it to the composting or digestion facility. And if it is a dry waste, so it needs to be transported to the incineration facility for energy production or some. other purposes. The density is another parameter. So the weight of a waste per unit volume. So whatever waste is generated per unit volume is defines the density, and it is uncompacted municipal solid waste usually ranges from 200 to 500 kilogram per meter cube. So this would be general density for the typical solid waste. The moisture can be calculated if some solid waste has like kitchen waste has a moisture content in it. So how we will calculate it? We will calculate like a wet weight minus dry weight divided by total, and we will multiply it 100. So M is the like moisture content, W is the weight of a sample as delivered in kg, and D is the weight of a sample after drying at 105 degrees Celsius. This is the normal oven temperature to make drying anything like whether it is waste or any other material. So a typical range of moisture content is around 20 to 40%, and it represents the extreme of waste in any arid climate and in a wet season of a region of high precipitation. However, value greater than 40 are not uncommon. So that could not be considered as a solid waste. It could be considered as semi-solid or liquid waste. For example, we are determining the moisture content of a sample from our following data. We have a food waste which has weight percent by 50, and moisture content is 70, paper waste is 45, and cardboard weight. So these are the percentage. I have suppose 100 kg of waste which has a 50% food waste, and paper waste is 45%, and others are like cardboard is 10%, plastic is 10%, and garden. So if the moisture content in the food waste is 70%, and paper waste is 6%, cardboard is 5%, and garden trimming and wood has some amount. So how we will calculate the moisture content in those? So we will use the same formula like a wet weight minus dry weight and divide by wet weight into 100. Okay. So first we will calculate the dry mass. What is the dry mass? Hmm. The food waste has a dry mass is 4.5. Paper waste has a, because it has a moisture content 70%, that's why it become a 4.5. Similarly, in paper weight, it is 42.3, and in total, the whole it becomes 79. So we will calculate like a wet waste minus dry waste. So it's 100 minus 79 divided by 100 into. So the total moisture will become or calculated as 21% in a whole solid waste that we have there in the previous slide. So a typical composition or physical characteristics or distribution, in other words, we can say, so metal is around 1.67%, wood is 0.88%, is like a lesser in amount. However, there is a significant amount is bio waste, that would also be say as kitchen waste, wet waste. So these are larger in amount in a solid waste, and household waste is there. And paper waste is 9.82%, plastic waste is 11.2. So some of the major contributor in a municipal solid waste. However, few are lesser contribution like wood waste, metal waste, and green waste, bulky waste. These are very less. So, for example, in some other study says that the waste could be different from another study. So, this study says that food waste has a 43%. However, paper and plastic is like less than 10%. Yard waste and wood waste it says 21%, but previous study says that the wood waste is like 0.8%. So study wise, study or location wise, the waste generation may vary. Okay. Even the moisture content may also vary. How much carbon is there in in a waste? How much nitrogen, phosphorus, and volatile solids are there? So these can also vary based on the location and type of waste that is generated. Municipal solid waste chemical characteristics. So characteristic when considering municipal solid waste. So it is important to do chemical characterization, and it also has some technology to process it, like thermal treatment, whether it is incineration, pyrolysis, or gasification. And you can also go for predicting the landfill behavior. So chemical characteristic is very important to know to process the municipal solid waste through these thermal treatment or landfill technologies. First one is the ultimate analysis. So ultimate analysis determines the elemental breakdown of the waste, mm, such as carbon, hydrogen, oxygen, nitrogen, and sulfur. These are the elemental composition that is there in a municipal solid waste. And this highlights the potential environmental concern, like the creation of a nitrogen oxide or sulfur oxide during the combustion. So if these compounds are there in a solid waste, and if the waste is being processed through incineration, pyrolysis, or gasification, so these compounds or these compositions like a carbon dioxide will combust and will make a carbon will combust in presence of oxygen. It will react and form a carbon dioxide and will emit into the atmosphere. And similarly, if nitrogen is there in the in the municipal solid waste, it will oxidized and form a nitrous oxide or NOx that will also goes into the atmosphere and impact to the environment. Sulfur is also, if there, then sulfur will form SOx compounds and it will emit into the environments. So we need to know how much amount of carbon, hydrogen, oxygen, nitrogen, and sulfur is there, so that we can calculate the amount that is going into the atmosphere. And after the combustion or incineration or pyrolysis, we can also get the composition that is there in the residue form. So we can do the mass balance, and we can to know what is amount is still in the S or in the biochar, and then what is amount is left into the environment. The proximate analysis measures the moisture content, volatile matter, fixed carbon. So proximate analysis is another kind of a characteristic, and it measures the moisture content, volatile matter, fixed carbon, and ash content. If there is a high ash content, it lowers the heating value and often requires the pretreatment for sorting. And calorific value is third kind of a characteristic. It talks about the energy, how much energy you can generate or it has. So the amount of a heat generated by burning the specific mass of waste or a specific kind of a waste. The typical value range from 800 to 3000 kilocalorie per kg. So if you are burning 1 kg of a municipal solid waste, you could earn around 800 to 3000 kilocalorie, it based on the what kind of a waste is there and how much calorific value is it has. It depends on the heavily on moisture. It also depends on the moisture level and the proportion of a paper or plastic. Okay. For example, if you're going to calculate the plastic approximate analysis, so the typical approximate analysis includes the moisture, ash, volatile matter, and fixed carbon content. So how you will you can calculate the moisture content similarly in as you done in the last time. The for the volatile matter, you can calculate the weight loss, which is obtained on a heating of 1 gram or 1 kg of sample of a substance at 950 degrees Celsius, or else like the temperature may vary 950 or 100 for 7 minutes in the absence of air. So the weight loss due to volatile matter is the total weight loss minus moisture. एंड वोलेटाइल मैटर परसेंटेज फॉर्म में कितना आएगा, वेट लॉस ड्यू टू द वोलेटाइल मैटर डिवाइड बाय द weight loss of a sample and multiplied by 100. So in that way you can calculate the volatile matters present in a municipal solid waste, the particular temperature and a particular time, and the S content will be calculated as a if S is present, or S is the weight of the residue that is obtained after the incineration or pyrolysis or after the gasification. Okay, after the complete combustion, so you can only consider the incineration or incineration. And 1 gram of some substance at 700 to 75 degrees Celsius. So if incineration is happening at 750 degrees Celsius or 700 degrees Celsius, and it is combusting all the municipal waste, if you are processing in a incineration, then the ash is generated will be calculated like a weight of a residue divided by the weight of a sample into 100. Similarly, you can also calculate the fixed carbon, how much fixed carbon is in there. So the fixed carbon is the material other than the ash. Okay, so if there is a carbon that does not vaporize when heated in the absence of air, like if you are doing the pyrolysis, so S is for the like a complete combustion in the case of incineration, but fixed carbon could be there if you are doing the pyrolysis in the control atmosphere, and it won't combust all the amount of municipal solid waste, and there would be some leftover like carbon materials or carbon type of a char material, and then that will be calculated using this formula, like a fixed carbon is equal to W weight percent in a wet waste is equal to 100 minus percentage of moisture plus percentage of S that is generated and percentage of. So if you add and minus with 100 like a total municipal waste, you will get the fixed carbon value. In a typical municipal solid waste, what would be the moisture content, volatile matters, fixed carbon, and glass, ash, and metal? So moisture content will be like a 15 to 40%, uh, and the volatile matters would be 40 to 60%. Depends on the type of municipal solid waste and location where it is being generated and how what kind of it is. And it also has a fixed carbon which ranging from 5 to 12%, and glass, ash, and other kind of a material could contribute around 15 to 30%. Municipal solid waste characteristics. Okay, so apart from physical and chemical characteristic, we also have a biological characteristics in third and fourth, which is the hazard characteristics. Environmental Protection Agency has decided that there should also be some hazard waste characteristics. So in biological characterization measures how radially the organic fraction of the waste will degrade. So it talks about the biodegradability of a municipal solid waste. It all indicates that the portion of a waste that can be broken down by microorganism. So if you are doing a anaerobic digestion or composting, there would be some amount of a biological or microbial consortium like microorganism, bacteria. Those microorganisms will break down the biomass or municipal solid waste. If it is a wet or organic biomass, then these microorganisms will consume, because those biomass will be the food for these microorganisms. These are microorganisms will consume such kind of a waste biomass, and they will produce some carbon dioxide or some sludge kind of a thing. And high biodegradability makes waste excellent for composting or anaerobic digestion, biomethanation. So CS4 is also generating. We will talk about in later slides how anaerobic digestion is happening. But it also, like, if you are considering anaerobic digestion, it also, because there is absence of air, and it creates a order and leachate. So these are the challenges in like anaerobic digestion or landfills. What about the hazard characteristics? When applicable, municipal solid waste is evaluated for hazardous properties using the four characteristics established by US. What are these four characteristics? Ignitability, waste that is easily combustible, and corrosivity, strongly acidic or basic waste that can corrode materials, and the reactivity, so the waste that is unstable, can react violently with water or generate toxic gases. And talking about the toxicity, so the waste that is releasing the toxic chemicals into the environment, so these kind of waste are toxic. Okay, so we can categorize those kind of waste based on the these four characteristics established by the Environmental Protection Agency in USA. Okay, so there are technologies, as we talk about earlier, solid waste and resource recovery technologies, because these technologies are important to utilize such kind of a solid, such huge amount of a solid waste that is being generated, and these technology either create energy or recycle the solid waste for some better value products or some similar kind of a value products. So solid waste and resource recovery technology is important to transport or discard the material into valuable resources such as energy, compost, and raw materials. And it also minimizes like a mini landfill. Like in most of earlier people only, or most of the solid waste they will do landfill and promote. So it will avoid the landfilling practices that is being done by Indian country or other some Asian countries. So that will be avoided if you are doing some recycling or energy generation thing. The approach is divided into material recovery, recycling, and waste to energy conversion. So this would be approach for the municipal solid waste. So first technology is a biological technology. Okay, for organic waste. Hmm. Anaerobic digestion and aerobic digestion composting is two important technology. So, what happen in anaerobic digestion? It will break down the organic waste in the absence of oxygen, and it will produce biogas. Biogas is a renewable energy source, and it will also produce a biofertilizer, like a nutrient rich digested use as a biofertilizer. Okay, this figure says if one side you are putting organic matter in a anaerobic digester, you will get two things. One is biogas, which is rich in methane, like more than 60%, and some amount of carbon dioxide is also there, around 40%. And the another side, you will get digested, which is considered as a biofertilizer or manure, which has some nutrients, and it can directly used in a agricultural land. What is aerobic digestion? Aerobic means you are providing a air. Anaerobic means you are not providing the air. So anaerobic composting में क्या होता है कि माइक्रो ऑर्गेनिज्म इन द प्रेजेंस ऑफ ऑक्सीजन stabilize the organic waste. Okay, and it produce the high quality compost for agriculture. So these are the similar kind of a thing, but if you are doing the aerobic digestion, you won't be getting methane. Instead, you will getting the carbon dioxide, because all of the carbon material that is there in a compost will oxidize as a carbon dioxide, and it will also produce some amount of heat around 40 to 70 degrees Celsius. And the formed compost, you will you can use directly into the agricultural land. Solid waste management and resource recovery technologies. Hmm. What are those? Those are like thermochemical and energy recovery technologies. So first we have talked about the biochemical technologies. Now these are the thermochemical and energy recovery technologies. Hmm. So first one is incineration or combustion. Second one is refuse derived fuel, and third one is the pyrolysis and gasification. So incineration means the complete combustion. You will burn the non-recyclable. Means if some municipal solid waste is recyclable, and so that you can use that in a recycling facility, but some of the MSW are non-recyclable, so that you can directly burn those to generate energy through the steam. And refuse derive, what it says that it process the combustible residual waste like plastic and paper into high energy fuel pellets, and it can be utilized by the industries like cement industry and other manufacturing industries. And pyrolysis is and gasification is important to generate like a bio oil, you know. So pyrolysis happen in low or zero no oxygen environment. However, gasification may happen in a steam environment. So you can put in MSW in an advanced thermal process, and that use high temperature in a low or zero oxygen environment to convert solid waste into syngas, bio oil, and biochar. So first technology was anaerobic digestion process. What was that? It will break down the materials. Okay. So you have for example, you have a biomass. Okay. So what happen? What will the first step? First step will be the hydrolysis, है ना? हाइड्रोलिसिस में क्या होता है कि द कॉम्प्लेक्स ऑर्गेनिक मॉलिक्यूल्स, है ना, दे विल ब्रेक डाउन इनटू सिंपलर sugars and amino acids in simple kind of compounds. And next step will be acidogenesis. तो एनारोबिक डाइजेशन में फोर इंपॉर्टेंट स्टेप्स हैपन होते हैं, है ना? हाइड्रोलिसिस, एसिडोजेनेसिस, एसिटोजेनेसिस एंड मेथनोजेनेसिस। हाइड्रोलिसिस क्या करता है कि कॉम्प्लेक्स ऑर्गेनिक मैटर बायोमास में जो भी होता है दैट विल बी ब्रोकन डाउन इनटू सिंपलर वन, है ना? polymers kind of a thing होती है that will broken down in simple like sugar and amino acids. Acidogenesis में क्या होता है, smaller organic molecules जो होते हैं उनको बैक्टीरिया क्या करता है, खा के वोलेटाइल फैटी एसिड, कार्बन डाइऑक्साइड एंड हाइड्रोजन में कन्वर्ट कर देता है ना, डाइजेस्ट कर देता है। एसिटोजेनेसिस में क्या होता है, एसिडोजेनेसिस फर्दर कन्वर्ट द एसिड्स दैट इज जनरेटेड फ्रॉम द बैक्टीरिया. So those acids will convert into acetic acid, hydrogen, and carbon dioxide. That thing happens in acetogenesis. And fourth was the methanogenesis, है ना? So methanogenesis में what happened there? Archaea uses these intermediate products, है ना? जो भी intermediate products फॉर्म हुए थे, है ना, acetogenesis में, those will convert into methane and carbon dioxide. So methane and carbon dioxide is the end product of anaerobic digestion process. However, you can modify this technology to stop in acetogenesis or acidogenesis step itself to get if you want only fatty acid, volatile acid, fatty acid, you can stop here in acetogenesis itself. Hmm. If you want acetic acid, you can stop the process at esterogenesis itself. So these are modifiable. Next one is the, okay, this one is also the anaerobic digestion. What product you can get, like it can apply in animal breeding solids. Like if you are getting some amount of biogas, so from the biogas you can produce electricity, you can produce heat, you can produce a vehicle fuel. Also you can produce natural gas directly, you can use in a household purposes, cooking food. uh, if you are getting digested like so as I already told that in the anaerobic digestion you will get two kind of a product. One was for biogas and one was digested. If you are getting digested, what kind of material you could prepare, you could use you can use that digested in a agricultural land. You can also use that digested in a solid form like a building material, crop irrigation, or animal bedding. So these are multiple purpose of utilizing digested as well as a biogas. However, as an input material in a anaerobic digestion could be manure, wastewater biosolids, food waste, other organics. So there are so much opportunity to utilize anaerobic digestion to manage municipal solid waste and produce in a valuable products. एरोबिक कंपोस्टिंग में क्या होता है कि in aerobic composting we will supply air. Aerobic method will relies on aerobic bacteria like a fungi and other microbes that will thrive in presence of oxygen. And these microbes and organisms will break down the waste that is there in a system, and they will release the carbon dioxide, water, and heat. Okay. So, for example, if you see in this figure, you will seeing that organic waste and oxygen is supplying in the system, and microorganisms is already present there. These microorganisms eat the organic waste in the presence of oxygen, and they will produce carbon dioxide, water, heat, and some compost. Okay. Talking about the thermochemical and energy recovery technologies. So, apart from biochemical, biological technologies, as we said, we can use thermochemical technologies to recovery energy. Okay. So, first one was the incineration, and there are also like torrefaction to produce bio oil, biochar technology, like a hydrothermal liquefaction technology you can use, and hydrothermal carbonation is also there, and pyrolysis gasification is also there. So these four technology mostly used for bio oil or biogas or biochar production, but incineration is used for energy production mostly. So if you are utilizing these kind of a municipal solid waste and producing a valuable energy or other kind of valuable co-products, so you are maintaining the circular economy. Talking about the comparison of a combustion, gasification, and pyrolysis. Okay, तो ऑक्सीडाइजिंग एजेंट में कंबशन में ग्रेटर देन स्टाइकोमेट्रिक सप्लाई ऑफ ऑक्सीजन, but in gasification में less than stoichiometric oxygen of steam or steam as oxidizing agent. तो कंबशन में तो ऑक्सीजन सप्लाई होता है, टेम्परेचर भी अराउंड 800 to 1200 डिग्री सेल्सियस होता है. Principal product is heat, and principal component of the gas carbon dioxide and H2O. Okay. बट इन गैसिफिकेशन में टेम्परेचर भी अराउंड 800 to 1200 डिग्री सेल्सियस होता है, बट द आउटपुट यू विल गेट हीट एंड कंबस्टिबल गैसेस, and as a product you can get hydrogen H2 and CO. But here you can use some water gas reaction so that you can convert this CO into hydrogen itself again. In a pyrolysis, what happen? You are not providing oxygen here. You can provide a control like a nitrogen to create a control atmosphere inside the pyrolysis reactor, and you are producing here biochar, biogas. uh, as biogas are like a syngas, and if you condense those kind of a biogas, you can get a bio oil. So pyrolysis is mostly used for bio oil production or gas production and biochar production. So there are most of the things are similar. uh, you are providing temperature, you are getting some energy. Some of the technology like combustion, for combustion using oxygen, but in calcification and pyrolysis you are not using the oxygen. Output from the thermochemical conversion technology. Hmm. So predominant components of the products from fast pyrolysis and gasification. है ना? Apart from incineration, so fast pyrolysis means you will get a higher amount of bio oil and a lesser amount of a biochar. If you are doing a fast pyrolysis, means you are providing high heat or high temperature and a less short residence time. So in a fast pyrolysis, you can get a larger amount of oil, tar, and water liquid as a fuel. However, in solid in a biochar, you can get 10 to 15% of a biochar and some amount of non-condensable gases as well. But in a gasification, what happens? You won't get much amount of oil or biochar, but you will get 85% of a gas, that is syngas. Okay, synthesis gas is like mostly produced through the gasification technology. Mm. And it has a temperature higher than pyrolysis, like more than 800 degrees Celsius. Mm. Talking about the incineration process or combustion process, so this technology is like mostly used for electricity or steam generation. This steam is directly used in a turbine and produce electricity. So although the technology is simple, but here the picture is little bit complicated. Okay, so first in this picture, starting from the left side, you will see that the biomass is sending into the pit, and some hanger will collect the biomass from the pit. It will process through the grate, and that biomass will burn here, and some biochar will generate, or some ash will generate here. Okay, so those ash contains some amount of metals, metallic components. That metallic components or ash can directly be used in a material or construction material production, but the steam or heat energy that is being generated from the combustion, that steam is generated and from the boiler and collected into the through the send it through the turbine. Steam turbine use that steam, and generator produce the electricity, but some amount of fly gas or fly ash is transported into the spray dryer, bag house, and then to the water vapor. So some amount of ash is also generated, and that is directly sent to the landfilling purposes. And the carbon dioxide is directly being released into the atmosphere. So this technology generates a large amount of carbon dioxide. Therefore, people are shifting from incineration to other kind of like recycling of waste materials after the proper segregation. Anaerobic digestion is also important if it is in landfill, but people are also shifting to the gasification to generate synthesis gas, so that this synthesis gas is a platform chemical and can be used for other kind of products. The pyrolysis is important for bio oil production or biochar production. So biomass or organic waste is first what happened there. They will first pre-treated by drying and grinding, and they will produce a uniform feedstock. That feedstock is further used in a pyrolysis reactor. Okay, in a absence of oxygen. Inside the reactor, the temperature is around 400 to 500 or 700 degrees Celsius. There won't be any oxygen present. Okay, and after the pyrolysis process, you will see that the gas is directly transporting or coming into the cyclone. What happened there? The cyclone will separate the charge that is there with the gas, and the gas will then send into or coming into the quencher. The quencher will cool that down, and we will get, after the quenching, we will get some amount of bio oil, and in a cyclone we will get some amount of a char. Okay, in a char collector, but some amount of non-condensable gases is also there that will again recycle back into the pyrolyzer. So this is the simple pyrolysis process. Okay, Although what is happening inside the pyrolysis reactor is not much known, okay, because there are no oxygen, only nitrogen or argon atmosphere will be there to maintain the, because if we apply oxygen, we will get like burn or combust all of the material. But the main purpose of pyrolysis to get the char and bio oil. गैसिफिकेशन में क्या होता है कि म्यूनिसिपल सॉलिड वेस्ट बायोमास जो भी है इट विल स्प्रेड इनटू द गैसिफायर फ्रॉम द टॉप ऑफ द tower. And in the drying zone, first one is the drying zone. Once you feed the solid waste from the top, you will that solid waste will reach into the drying zone. Okay. In the drying zone में क्या होता है कि moisture जो भी रहता है biomass that will be removed from the solid waste. And next one is the devolatilization. ये एक तरह से pyrolysis भी होता है ना. तो इसमें क्या होता है कि वॉट एवर द वोलेटाइल्स विल बी प्रेजेंट दैट विल बी रिलीज्ड out, and it will produce like some amount of gases, tar and char. And next is the partial oxidation phase or stage. Here what happen, a control amount of oxygen will be and steam will be supplied here, and it will cause a partial oxidation instead of complete combustion. Okay, we are not providing a huge amount of oxygen, we are just putting a small amount of oxygen or steam to make a partial combustion. Mm. After that, in a next step, what happened there, the generated heat that will convert the carbon rich char into syngas. Okay, whatever the charge is biochar is being produced, that will convert it into syngas. The main consisting mainly it consists of carbon dioxide and hydrogen. So the carbon dioxide and hydrogen will reach into the top. Okay, sorry, carbon monoxide. So carbon monoxide can be used in a water gas shift reaction to enhance the production of hydrogen. But here it's showing that the hydrogen and CO is directly cooled down, and it directly is sent into the gas turbine or collection unit. At the bottom, inorganic materials melt and are removed as a molten slag or ash. Some amount of molten or ash is also being generated from the gasification process, and that is collected at the bottom of this reactor. And the syngas cleaning is important for the producing electricity or gas turbine में use करने से पहले. And जो भी fuel like hydrogen fuel is generate हो रहा है, its cleaning is also important at the end phase. तो pyrolysis and gasification एक साथ process है. Okay, तो ये how it divides in multiple steps, like there are 4 steps. First is drying. Okay. As I already discussed in previous slide, first step was drying. It happens at 100 to 200 degrees Celsius. Second step is the primary pyrolysis. It happens at 200 to 500. Mostly people you do use 500 degrees Celsius for the pyrolysis to degrade the molecules that is there in the waste, and water vapors will generate, and they will be evaporated or condensed. Hmm. The tar, like aliphatics, aromatic compounds in the tar will be, these compounds will be there in the tar, and the biochar will also generate and a gas like consisting of carbon dioxide, carbon monoxide, hydrogen that will be generating in a pyrolysis. So if you are condensing the gas, you can condense in a pyrolysis process itself, but that gas will again in or transporter. If you are using combined pyrolysis and gasification reactor, then that gas and char will sent into the secondary pyrolysis or gasification unit. हम्म. तो जो चार होता है that will है ना combust, है ना, and it will produce carbon monoxide, carbon dioxide, hydrogen and other kind of gaseous. Mm. So this is the simple, not that much simple, but a little bit tricky if you are going for a pyrolysis and gasification together. But pyrolysis is a one-step process. Gasification is a multi-step process. It happens is a higher than 500, like around 800, 900 degrees Celsius. But pyrolysis can happen only at 500 degrees Celsius or 400 degrees Celsius. Gasification mostly used for gaseous products like a syngas, synthesis gas production. But pyrolysis mostly used for the biochar or biooil production. Hmm. Talking about the refuse derived fuel. If you have a municipal solid waste and that is either landfill by or transforming combustible materials like paper, plastic, and textile into high energy homogeneous fuel pellets. तो उस केस में रिफ्यूज डिराइव टेक्नोलॉजी काइंड ऑफ अ थिंग कैन बी यूज्ड. ये क्या करता है, इट विल like it serves as a vital renewable energy source that directly replaces the fossil fuel in high heat industries like cement industry. तो ये pellet kind of a thing बना देता है ना. तो वो पिलेट जो है डायरेक्टली सीमेंट इंडस्ट्री वगैरह में है ना यूज हो जाते हैं, उसमें सीमेंट किल्न वगैरह में हीटिंग पर्पज के लिए, हीट जनरेशन के लिए. सो रिफ्यूज डिराइव फ्यूल इज मोस्टली like this technology mostly the purpose of this technology is to prepare RDF pellets है ना. प्रोसेस क्या होती है, पहले शॉर्टिंग और सेपरेशन करते हैं, शेडिंग करते हैं, ड्राइंग भी करते हैं, एंड देन डेंसिफाई करते हैं है ना पेलेटाइजेशन में. Nutrient recovery via struvite precipitation from wastewater treatment plants. है ना, wastewater treatment also generates a huge amount of sludge है ना in a wastewater treatment plant. तो उसमें क्या होता है कि जो sludge होता है it has some amount of phosphorus, nitrogen as well, and some other kind of nutrients like magnesium, कैल्शियम. तो मोस्टली जो होता है मेजर अमाउंट में फॉस्फेट फॉर्म में होता है, फॉस्फोरस PO4 3 नेगेटिव. अमोनिया नाइट्रोजन जो होता है अमोनियम फॉर्म में होता है NH4 प्लस पॉजिटिव. और मैग्नीशियम इज लेसर इन अमाउंट बट इट्स फॉर्म इज लाइक मैग्नीशियम 2 पॉजिटिव है ना. तो वेस्ट वाटर में से जो स्लज होता है वो कलेक्ट हो जाता है. उस स्लज में से है ना स्ट्रोवाइड प्रेसिपिटेशन मेथड यूज करते हैं है ना टू रिकवर द न्यूट्रिएंट है ना. और उसको न्यूट्रिएंट को रिकवर करने के बाद वी कैन यूज दैट न्यूट्रिएंट्स इन एज अ स्लो रिलीज फर्टिलाइजर इन एग्रीकल्चरल सेक्टर. So how it happens है ना, precipitation process is generally carried out in a reactor under the control pH है ना. at different pH like pH around 8 to 9 है ना. अगर pH 8 to 9 मेंटेन रखते हैं तो क्या करता है कि जो स्लज है ना स्ट्रोवाइट फॉर्म करना हो शुरू कर देता है, स्ट्रोवाइट क्रिस्टल फॉर्म करना शुरू कर देता है ना. मैग्नीशियम में बी एडेड इफ रिक्वायर्ड टू अचीव द प्रॉपर स्टोइकियोमेट्रिक रेशियो ऑफ प्रेसिपिटेशन. यू कैन एड मैग्नीशियम to enhance the precipitation. Struvite crystal form according to the reaction like a Mg2 positive will react with ammonium plus ammonium ion and phosphate ion in the water, and it will form this kind of struvite crystals like MgNH4PO4 into 6H2O. Samples are collected at different time intervals and filtered to separate the precipitate to white. The remaining phosphorus concentration in the liquid is measured using calorimetric analysis. You can use like a calorimetric analysis means you can use some indicators to colorize it, and whatever the density of a color in a of a sample, you can use that in a spectrophotometer to see that what is the concentration of nitrogen, phosphorus, or other kind. The recovered struvite is analyzed and can be used in a sustainable fertilizer. Hmm. तो जो भी न्यूट्रिएंट रिकवर किया है दैट इज इम्पोर्टेंट टू यूटिलाइज इन एज अ फर्टिलाइजर इन एग्रीकल्चरल सेक्टर, and it will reduce the nutrient pollution at one side. However, it will also reduce the nutrient import from the other countries. So here we are also maintaining the circular economy. We are treating the wastewater from the wastewater treatment plant. We are also recovering the nutrients from the waste sludge that is there, and these sludge is being used to form a fertilizer like nitrogen and phosphorus based fertilizer, and it will reduce the import. And so this is the circular economy principle based method. Hmm. This is picture of whatever I have explained to recover the nutrient from wastewater. So sample preparation, like sample collection from the wastewater treatment plant, is the first step. You will centrifuge is at the bottom of this centrifuge. While you can see there is some amount of like a solid is settled at the bottom, you can filter it, and after filtration, you can use some magnesium to enhance the formation of struvite, and then again you can filter it. After that, you can get the phosphorus or colorimetric analysis to see the concentration of precipitate like phosphorus, phosphate in that. The circular economic concept in sanitation क्या कहता है? There are three pillars of circular economic sanitation, है ना? The system aims to design out waste and pollution, keep biological products circulating at their highest value, and actively regenerate natural topsoil and aquatic system. है ना, इसके 8 R हैं, 8 R's are there, 8 R frameworks for wash, है ना, क्या है वो, that will adopted especially for water sanitation and hygiene in a wash water sanitation systems. This framework uses tailored strategy like rethink, reuse, reduce, recover, है ना, to ensure resource optimization while maintaining safely climate and resilient and social inclusion, है ना. ये 8 R नहीं होगा, आई थिंक 4 R होगा. ओके. Segregation at source. So this foundational approach separates urine, patient, and grey water at toilet level to simplify treatment and maximize the purity of recovered products. फिगर में क्या कहता है कि रिड्यूस द इन्वायरमेंटल फुटप्रिंट, जनरेट इंक्रीज द इनकम, मिनिमाइज वेस्ट, रिड्यूस रिसोर्स डिफिशियंसी, है ना. तो वॉट एवर वेस्ट इज जनरेटेड, है ना, यू कैन रिसाइकल इट, रीयूज इट, है ना, एज अ रिसोर्स to reduce the toxicity, है ना, to produce the green products or cleaner products, है ना, using a waste resource. It will provide a better service to extend lifespan, and it will also enhance or end of life of remanufacturing as a fresh product. How we maintain the circular economy concept in a sanitation and waste management? What will be the process? Actually, this picture is little blurry, but I think it's readable. So we have industries, cities, and villages. These things are generating wastewater. वेस्ट वाटर से क्या होता है कि न्यूट्रिएंट रिकवरी हो सकता है. यू कैन प्रोड्यूस अ ट्रीटेड वेस्ट वाटर, एंड there are also anaerobic digestion AD process to recover biogas, biosolids, and we can recover nutrients from nutrient recovery process. We can also treat the wastewater in a wastewater treatment facility to get the treated water, and a treated water directly can be used in agricultural purposes, and the nutrients that is recovered from wastewater treatment plants can be used in a farming sector, because these nutrients consist of like nitrogen, phosphorus, and potash kind of a thing, and organic manure also is there, so that it can directly use in agricultural purpose based on the requirement of the soil. The for biosolids like a manure will be directly sending into the agriculture, but biogas that is there from the anaerobic digestion, these biogas can be used to produce electricity or other kind of a domestic fuel. the process of maintaining circular economy concept in sanitation and waste management. So what are those processes that I already discussed? Nutrients and organic recovery, energy recovery, water reclamation, and material recovery. The transportation process is means of transportation is co-composting, vermicomposting, black soldier, fly libres, farming, and pyrolysis. This kind of transformation process and transport the waste into some valuable high-end products. That I what would be the benefit of a nutrient organic recovery? Recovers the nutrients, improves soil health, and supports the sustainable agriculture. Similarly, in the energy recovery, there are an anaerobic digestion like biological process, thermal process is there, and water reclamation में क्या होता है कि advanced filtration, biological treatment, and multi-stage stabilization or some natural treatment technology is also there. So there are some transportation processes, and these transformation process will convert the waste into some high value end products. Okay, and it has major benefits in the sector of fertilizer, agricultural sector, and energy sector as well. So this is the same thing, potential circular economy of plastic waste. If there is a plastic waste, how it is being recovered? Like plastic waste is enriched to generate electricity through the either through the incineration or through the gasification process. Nowadays, people are doing gasification because if you are co-gasifying the plastic waste with a municipal solid waste, you can generate a huge amount of hydrogen gas because plastic don't have like a moisture or something else, so that it generates a high amount of hydrogen if you are generating the co-gasifying the plastic waste with municipal solid waste. सर्कुलर इकोनॉमी है ना. सिमिलर थिंग्स सर्कुलर इकोनॉमी क्या होता है कि रिसोर्स कंजर्वेशन, रिफ्यूज, रिड्यूस. रिसोर्स कंजर्वेशन में क्या होता है कि if you are conserving the resource means you are maintaining the minerals in the earth, you maintaining the air quality, you're maintaining the low resource consumption, maintaining the water quality as well as water availability, soil health as well as forest. So resource conservation is very important to maintain the circular or to keep in practice circular economy and its principles. Refuse means non-recyclable objects, metallic foils, wax boxes. These could be refused, and if recyclable materials are there like plastic, metals, papers, economic advantage with environmental safety. So these kind of things can be recycled. And if you are reducing the carbon emission, food waste, empty consumption, you are also maintaining the circular economy. Mm. And increasing the product life. Affordable research is required, nature based solution is required, cleaner production is required, green design is required, and to increasing the product life. For example, nature based solution, talking about the nature based solution. Currently, we are using wastewater treatment. There are some like primary treatment, secondary, tertiary treatment. But if instead using primary, secondary, tertiary, we can directly put their constructed wetlands or waste stabilization pond. That is the nature waste solution for the treating wastewater. So it will not use a huge amount of energy and chemicals in the process. So some kind of a practice reduce the emission and enhance the life, product life. Okay, so thank you guys. Any question from this lecture?
Lose the
Uh,
Sir.
Excuse me, sir.
yep. Yeah. See.
I have a doubt from the presentation, not from the lecture. Uh,
Hmm. Yeah.
I wanted to ask, like, how long should the presentation be, and how much time we should spend on each slide, and how much slides we should make.
You can make a 5 to 6 slide. You can take 5 to 6 minutes. Each slide can like 1 minute or 1.5 minutes. So
Oh,
yeah, 7 to 8 minutes is more than enough. to present 5 to 6 slide. Okay.
Okay. Yes.
Any else? Any other? If there is no question, so I'm going to end the meeting today. So I think we will meet on Monday, right? At 10.
Yes, sir.
Okay. See you there. Bye bye.
Okay, sir. Bye.